Fragmented, the podcast where we capture what's top of mind for Android developers. I'm your host, Kaushik. In our last episode, we announced a big reboot for Fragmented. From now on, I want to tackle topics that Android developers are actively discussing, excited about, or even find frustrating. So what's on the agenda today? One topic that's been both a cornerstone and a thorn for Android developers over the years is dependency injection. So why is DI interesting now? If you start a conversation about DI with any Android developer, what's one word you can almost bet will come up? Dagger. But here's the thing. While Dagger has been the go-to solution in DI conversations, I think things are changing. There's a new king in the dependency injection town, at least in my humble opinion, and it's actually not a single library, but a combination of two that work really, really well. Kotlin Inject and Kotlin Inject Anvil. To understand why all of this is significant, I'm going to briefly walk down memory lane and talk about the solutions that have emerged over time. Then we'll end with the exciting part of this episode where I talk to an expert who actually maintains one of these libraries. Let's get started. So, back in 2012, Square introduced the first version of Dagger, or Dagger V1. While, even at that time, there were other DI frameworks like Juice, RoboJuice, a bunch of others. Dagger was designed specifically with Android in mind. A core issue in Android is that you cannot instantiate activities or fragments with custom constructors because the framework manages their life cycles. So traditional constructor injection is just not very straightforward, and you cannot manage state effectively across some of these lifecycle changes. Dagger addressed this, and they did this in a clever way through code generation, which was definitely quite novel an idea at the time. The generated code would provide a way for framework classes to retrieve dependencies with all the necessary boilerplate that you have to otherwise write. So what was the problem with the Dagger 1? Why didn't we just keep using it forever? Performance. Dagger 1 relied on reflection to generate its boilerplate code. If you remember in those days, reflection is a very big no-no in the Android world. And there was one company in particular that was writing large Android apps and facing these challenges more than anyone. That company would be Google. So in 2015, Google released its new version of Dagger, Dagger 2, a complete rewrite aimed specifically at improving performance. They moved from reflection to using compile time code generation, and there were a bunch of other massive performance gains with Dagger 2. But there was a catch. While they made it much more performant, it also introduced a lot of complexity. Concepts like components were introduced in addition to modules, and the API honestly just became more intricate and less intuitive. Setting it up also required a pretty big, steep learning curve. Some developers stuck with Dagger 1 because, despite the performance hit, it was simpler. But when Square officially deprecated Dagger 1 and, relinquished stewardship to Google for Dagger, it was kind of time to move on. But in 2017 again, Google released an update to Dagger 2. This was Dagger 2.10 or Dagger 2.10. And in it, there was a specific module or package called Dagger.Android with the hope of reducing boilerplate and making it really easy for Android developers to start using Dagger again. This came to be known as Dagger-Android. So if you see that in blog posts, that's what it refers to. So did it help? Not exactly. Dagger Android also added multiple layers of abstractions, which many found even more confusing. Instead of simplifying Dagger, it sometimes made the dependency graph even harder to follow. And let's be honest, the documentation up to this point was notoriously tough. I admire Square, but they started those damn thermosiphon examples. I had to even learn what a thermosiphon was before understanding the process of coffee making and all the analogies, and then finding out how Dagger is to be used. But anyway, I digress. Okay, if you're following this timeline somewhat closely, we're in 2017 now, and something pretty big happened at Google I/O during this year.
There is one more thing. We have never added a new programming language to Android, and today we're making Kotlin an officially supported language in Android.
So, leveraging Kotlin's features, a library emerged aiming to simplify DI even more using Kotlin's DSLs. And this was Coin. That's with a K, because this was the dark period where everyone released a Kotlin library and put a K right at the top. So why did Coin gain popularity? Honestly, there were just two big reasons. One, it was really easy to use. Two, it was really easy to set up. And, they really leaned heavily on the Kotlin and DSL parts of it to make the API so much more pleasant. But there was a couple of sticking points even with Coin. Coin used the service locator pattern, and this sparked many a debate and flame wars in the community. And honestly, while this was all helpful in the short term, as apps grew larger, the boilerplate also grew in some ways with this pattern. There was also the minor issue of dependencies now being a little more directly coupled to the service locator directly. All right, let's move along the timeline. So seeing some of the challenges that we had with Dagger Android and not even looking at Coin, Google was chugging along on the side and introduced another variant or extension to apply on Dagger called Hilt. This was as recently as 2020. So, was Hilt better? I gotta say, yeah, it is. And even to this day, it is the official stance and recommendation from Google. But around the same time, in around 2020, more apps were using Kotlin and apps were becoming larger. And as a consequence of this, build times were starting to take a hit. So the whole community shifted towards this philosophy of app modularization. And I'll tell you this, if you thought integrating Dagger was hard, integrating Dagger into a multi-module app setup was not fun at all. So the prodigal child of open source, Square, came back and tackled this problem head on by introducing Anvil. Anvil worked alongside Dagger, and it was another library, but it greatly reduced boilerplate by generating factory classes and simplifying the module setup in many ways. Square open sourced this at around 2020. And honestly, if you don't religiously follow everything that Google recommends, this is kind of the de-facto recommendation from the community today. For what it's worth, I use this at Instacart too for a lot of the apps. In this recap, by the way, I'd be remiss to not mention manual dependency injection as a movement that, some people started to adopt. There's just no magic there. No code generation, no reflection. Just keep things simple and wire it up yourself. I'm personally not a great fan of manual DI, mostly because, apps organically start to become bigger ones and nobody wakes up one day and says, okay, hey, my app today is a big app and everything has become difficult. The complexity and boilerplate very similarly starts to creep up if you start to manage things manually. But speaking of what I am a fan of, recently a new library has gained traction, Kotlin Inject. It was started by Eva with the username Evant, and that name should sound familiar to a lot of us, especially people who used to use RX Java in the Java days, because there was this library called Gradle Retro Lambda, which was a lifesaver. So it's the same person who built that library. So why is this a big deal? Firstly, Kotlin Inject simplifies DI by not supporting a host of features that you would otherwise find with, say, Dagger 2. As a simple example, it only has the concept of components, no modules. This harkens back to the time of Dagger 1, where I actually preferred some of how these things work. Also, it only supports constructor injection. As an Android developer, that might worry you, but I'll add a link to the show notes. It's very much possible to inject into your activities and fragments. So in not supporting a host of other features, Kotlin Inject actually greatly simplifies the API that you as a developer have to encounter and use. Second, it's built to work seamlessly with Kotlin Multi-Platform, KMP. This has become such a rallying cry in the community. And by the way, only Coin and Kotlin Inject support KMP. So many people have started to adopt this. Another development, most recently, as of a month or two ago, a group from Amazon released this library called Kotlin Inject Anvil. And it's exactly as the name sounds. They've effectively taken all the goodness from Anvil and applied it on top of Kotlin inject and chef's kiss. For the first time, I think dependency injection on Android just makes sense. The setup is straightforward, the concepts are easier to grasp, and honestly, the boilerplate is minimal. Starting a new project no longer means you have to dread your whole DI setup. I actually have a simple playground Android app that I'll throw a link in the show notes to, where I use Kotlin inject in a multi-module setup. It's simple, and honestly, I think the DI is very manageable. But I want to make sure I was on the right path. I needed to talk to someone with authority who can speak to some of these questions that I have. So I asked a friend and expert in the field to help answer a few questions. Let me introduce you to Ralf. Welcome to the show, Ralf.
Thank you, Kaushik. Thanks for having me.
Ralf, can you, before we start, just tell a little about yourself, please?
Sure. So my name's Ralf. I'm a principal engineer at Amazon, focusing on the delivery app that runs in the Rivian delivery events. And there we have a bunch of exciting projects.
So it sounds like you've dealt a lot with Kotlin inject. And in fact, you are the primary maintainer for Kotlin inject Anvil, right?
Yes.
Thank you so much for that. Firstly, it's been a lifesaver. Why did you even consider Kotlin inject in the first place? Letting alone the Anvil piece? Why pick Kotlin inject?
Yeah, so about a year ago, we shifted our direction more and more to Kotlin multi-platform. And we wanted to bring our existing architecture that we had from Android to KMP. In the Android world, in particular, Dagger 2 and Anvil were essential for us to make everything work seamless, improve developer productivity, remove boilerplate, and so on. And we wanted to have the same experience in Kotlin multi-platform. And fortunately, Kotlin inject existed at that time already. And I like to call it the Dagger 2 for KMP. It provides a very, very similar feature set as Dagger 2. And this is something that we wanted to preserve in the KMP world.
Can you talk specifically about what prompted you to anvilize Kotlin inject? Because Kotlin inject, you could use it in the KMP world, and maybe this also goes into what's the benefits of Anvil period, even for Dagger 2, right? What prompted that?
In fact, yes, like you said, it was a very similar journey to developing Anvil for Dagger 2 in the first place. We knew when we would adopt Kotlin inject that it will work for us. It's a great framework. It works out of the box. But there was some overhead in the way we structure our code, in the way we modularize our code. And we wanted to avoid this overhead. And back then, we decided to adopt Anvil for Dagger 2. And we went the same way this time, that we wanted to have a similar solution, but it didn't exist at this time. So initially, we adopted Kotlin inject by itself, but knew that we had to do something about it long term.
Can you give a quick snippet or two? What are some of those examples of that overhead that you felt Anvil made easier?
Sure. So Kotlin inject, similar to Dagger 2, has really three components. There's things where you provide stuff. In Dagger 2, it's a module. In Kotlin inject, it's a component where you write these provider methods. And then you have an injection side, and in the middle, what connects both of these sides is the component. So in Kotlin inject, you write these components, you provide objects to your objects graph, and then you have to bring these components or component interfaces together in a final component. And this is where you add super types in Kotlin inject. And the list of the super types that you have in your final component, it grew for us. Every time we wrote a new provider method, new module, we had to add this to the final component. And this is something that Anvil automates for us. It makes these connections for us and generates this, what we consider boilerplate.
Dagger is one of the most established libraries out there, and it's backed by Google, right? So there is a sense of comfort in using Dagger and knowing that there will always be a maintainer, right? How did you make that decision for a company as big as Amazon, right? Why did you pick Kotlin inject? Because it doesn't necessarily have as big a following or backing as someone like Google. Are you worried that there's a chance it'll stop being maintained?
That's true. And in fact, that's one of our biggest concerns, the maintenance part. There is no big company behind it, but we felt like the risk is lower because it's an open source project. It's currently well maintained. There are multiple contributors. We contributed a little bit whenever we could. Even if the core maintainer ever stops supporting the framework, we could carry it forward. The reason why we moved on from Dagger 2 was mainly that we started writing more and more code in Kotlin multi-platform, and there Dagger 2 simply doesn't work. We cannot bring Dagger 2 to the iOS side.
Right.
So we initially adopted Kotlin inject in the KMP code, kept Dagger 2 in the Android code, but this, of course, was also overhead because you have to bridge both object graphs at runtime, two different frameworks, roughly working the same way. That became challenging. So just recently, we decided to ditch Dagger 2 altogether and fully migrate to Kotlin inject.
Have you looked at the performance implications of Kotlin inject? Is there anything that we should be worried about?
Not really. So we are not worried. We did some testing. There is a slight overhead at runtime in that sense that Dagger 2 is heavily optimized for the runtime use case. And Kotlin inject doesn't attempt to go that far, and that's fine. But usually, in our experience, when you find bottlenecks in your app in regards to performance, it's usually not your DI framework. Usually we have other performance issues like disk IO on the main thread, these kinds of things. So we are not really worried about the runtime performance. The second aspect, Dagger 2 and Kotlin inject are interesting is the build time. They are both compile time frameworks, meaning they generate the object graph at compile time. And we noticed that Kotlin inject actually improves our build time slightly because Dagger 2 is a Java annotation processor. It generates Java code. These extra steps are more costly than Kotlin inject using Kotlin simple processing, KSP.
If you were starting an Android app from scratch, what would you use?
That's a tricky question. It really depends on the use cases. If you're certain that you will stay on Android, then I would probably stick with Dagger 2 today. But this also depends whether you want to adopt Anvil. Anvil for Dagger 2 currently blocks Kotlin 2.0. So there's some challenges there and also workarounds with a fork. But that was also one of the main motivators to get rid of Dagger 2 for us entirely. So I would still consider Dagger 2 and the original Anvil. But if you even in the far future consider to use Kotlin multi-platform, then I would definitely start with Kotlin inject these days.
And that's actually a good distinction you called out. If you plan to use the K2 compiler, right, we don't have a stable solution other than, say using something other than Dagger today, right? So that's also a big reason to use Kotlin inject. And Kotlin inject Anvil does not have that limitation either.
No, it doesn't. And that's right. This limitation purely exists in the Anvil version for Dagger 2 today. And Kotlin inject Anvil, what we've written, is compatible with Kotlin 2 from day one.
Ralf, thank you so much. Where can folks find some of your awesome work?
The best way is probably through my website where I link all my socials.
And we will add a link to that. Thank you so much, Ralf.
Thank you so much, Kaushik.
I never thought I'd say this, but I'm excited about dependency injection again. I hope you all are too. Thank you so much for listening. I will catch you all 2 weeks from now in the next episode.